common denominator? I hardly know her.
Well, hello everybody, and welcome back to another episode of Maths. In the last several videos, we've been going on this journey with fractions, and we've seen that fractions, although a little different, are still numbers, right? They're these decimals, basically. The same thing as decimals, and in the last few videos, we've seen how to convert between decimals and fractions. But the point is that they're numbers. So since they're numbers, that kind of raises the question, well, can we do normal number things with them? Can we add them? Can we subtract them? So on and so forth. And the answer is yes, we 100% can. So that's what we're going to be discussing in today's video, how to add fractions, and we're going to go from there. So your first instinct with adding fractions, if I had something like a half plus a quarter, might be, all right, well, we know how to convert these into decimals, and we know how to add decimals, right? So if we just convert these into decimals, we know a half, if we do the long division, we'll get 0.5, and a quarter, if we do the long division, we'll get 0.25. So then when we add these up, we're going to get 0.75. And then we know how to convert back to fractions, right? So when we convert 0.75 back into a fraction, we will get 3/4. All right, so we technically already know how to add fractions. Great. The thing is that this is really long, right? It involves two different conversions, and surely there's a method that's better where we can just keep everything within the world of fractions. And there is, and that's what we're going to be discussing today. So the first situation for adding fractions is where we have like denominators. So that'll be a situation where we have something like a fifth, and we're adding it to, let's say, 3/5. All right. So in order to add these, well, let's start by visualizing what this looks like. So if I split this up into 5 pieces, we know that this 1/5 is going to give us, well, one of the 5 pieces, right? That's what it means to be a fifth. And 3/5 gives us 3 of the 5 pieces. So if I shade in these 3 pieces here, how many pieces are shaded in total? 4. So adding fractions is pretty natural when it has the same denominator. We just add the numerators, 1 plus 3 is 4, and we get 4/5, right? Now, one thing a lot of students might think is, well, shouldn't we also add the 5s, add the denominators? But the thing is, this fifth part is kind of representing the size of our fraction, kind of like the size of the pieces that we're splitting it up into. And the numerator is how many of those pieces we actually have. So this is like saying we have 1 of these pieces, and this is like saying we have 3 of these pieces. The fifth is just indicating kind of the size of the piece. So since they're the same size piece, we're just saying we have 4 of those pieces here, right? 1, 2, 3, 4. So another example would be, what if we had an eighth and we added 3/8 to it? All right, so we could draw this out, but if we also know that it's just adding the numerators because they have the same denominator, we can say, okay, 1 plus 3 is 4, so this becomes 4/8. And let's not forget, we should always simplify our fractions. So 4/8 can be simplified, since 4 and 8 both can be divided by 4. So if we divide the numerator and denominator by 4 each, we get that this corresponds to half. So 1/8 plus 3/8, which gives us 4/8. Right, 4 of the 8 pieces are shaded, so that means a half of them are shaded. So if I did 1/3 plus 2/3, again we add the numerators, so we get 3/3. Alright, so 3/3, well, we know that's just 1. And this makes sense, right? We have something that we're splitting into 3 pieces, we're shading in 1 piece, then we're shading in 2 more. We've shaded in all the pieces, so this gives us 1. So that is how you add fractions when we have like denominators. It's pretty simple, it's just adding the numerators. So now what if we didn't have common denominators? What if we didn't have the denominators where they're the same? So let's consider that. So before we do that, let me ask you something like this. Let's say I have 3 apples. Okay, so those are my poorly drawn apples. And let's say I have 2 oranges, which I'm just going to uncreatively draw as circles here. So I got 3 apples and 2 oranges. Now, if I said, all right, 3 apples plus 2 oranges, how many apples does that give me? Well, we still have the 3 apples, but we weren't really able to add the oranges, right? Because, well, oranges aren't apples. And if I said 3 apples plus 2 oranges, how many oranges does that give me? Well, again, it doesn't really make too much sense because these apples aren't oranges, so we can't really add these two things. Yeah, we see 3 plus 2 is 5, but we can't really think of it in terms of 5 apples or 5 oranges because, well, we don't have 5 apples or 5 oranges. These are two different things. So the only way we could add them together and say it's 5 is if we said that, well, apples, those are fruit, right? And oranges are also fruit. So in total, we have 5 pieces of fruit. So the only way we were able to say that 3 plus 2 was 5 was making this commonality between them. So instead of considering apples or oranges, we considered them as fruit because that is what they both are. That's a more abstract category that these both fall into. So we're going to use a very similar idea with finding what are called common denominators. So if I had a situation of a third and I'm adding a half to it, in this situation, we can't just add these up. This is basically saying we're looking at a rectangle divided into 3 pieces, and we're looking at one of those pieces. Whereas this one is saying we're looking at the same rectangle but divided into 2 pieces, where this is one of those pieces. These pieces are the same size. We can't just add them up and say it's however many pieces because we're not looking at the same size of piece. Just like up here, we weren't looking at the same type of thing, right? So the question is now, how do we make these into something where it's common? Well, if we just imagined for a second that I split this up here, each of these pieces into 2 more pieces, we'll see that I get 6 pieces in total, and I've shaved in 2 of the 6 pieces. And this also makes sense since 2 over 6 equals 1/3, right? They're the same fraction, it's just a less simplified fraction. We essentially multiplied the numerator and denominator by 2, right? So 1/3 is the same as 2/6, right? 2 of these 6 pieces are shaded in. And now what I'm going to do over here is I'm going to split these 2 pieces up into 3 each. So now we see that 3 pieces out of the 6 are shaded in, right? We have 1, 2, 3, 4, 5, 6 pieces now, and 3 of them are shaded in. So and we know that's the same as 1/2, right? Since 1 times 3 is 3, and 2 times 3 is 6, so these are the same fraction, they're equivalent fractions. This is just a little less simplified. But by doing this, notice I've split both of these rectangles up into 6 pieces now. And now they're both fractions out of 6. And we know how to add fractions with like denominators, right? So now when we add these up, 2 plus 3 is 5, we're going to get 5 out of 6. So what did I do here? I basically was able to re-express these areas here where I split them up into the same amount of pieces, and by doing that, we were able to get a common denominator. Just like up here, we were able to say, okay, instead of apples and oranges, we're just going to think about them as their commonality of fruit, right? And then we were able to add them. So now the question is how did I know to make it 6, right? Where did I pull that number out of? So this is where the method for finding a common denominator comes into play. So the way we got to 6 was by basically taking 2 and multiplying it by 3. So 6 was a multiple of 2, right? Similarly, 6 is a multiple of 3. So we essentially need to find a common multiple of our two denominators. All right, so we need to find a common multiple of these two things. But this wasn't the only common multiple of 3 and 2, right? For example, 12 is a common multiple of 3 and 2. So if instead I said, okay, 1/3, that's going to be 4 out of 12, right? Because 3 times 4 is 12, so we get 4/12. And 1/2 I said was 6 out of 12, right? Since 1 times 6 is 6 and 2 times 6 is 12, so those are equivalent fractions. And then I added them, I would get 10 out of 12. But then 10 out of 12 I can simplify back down into 5/6, so we get the same thing, right? But this is a little less efficient because we had a bigger fraction here. And that's because we chose a bigger multiple, right? We chose a multiple that was unnecessarily big. 6 was a better multiple to choose because it was smaller, right? So it led to a simpler solution faster. So the question is now, how do we choose the optimal common multiple? Well, where have we seen an optimal common multiple? That's right, with lowest common multiple. So if we find the lowest common multiple of the denominators, that's going to be our best method about adding these fractions. I think it's really cool that in this unit, we've seen that greatest common factor has been relevant, co-primes have been relevant, and now even lowest common multiple has been relevant. It's almost like I made those videos before this for a reason. But I just think it's really cool connections that aren't always made very clear. So yeah, we're going to be looking for the lowest common multiple of the denominators. The lowest common multiple of 3 and 2 was 6. All right, so let's try another example. All right, so let's do 1/5 plus 3/10. So what we want to do, since we have a different denominator, we need to find our lowest common multiple. So it's the lowest common multiple of 5 and 10. Well, the prime factorization of 5 is just 5, because 5 is prime. And the prime factorization of 10 is going to be 2 times 5. So the lowest common multiple, remember to find that, we want to make sure that both of these numbers are covered. So if we just do 2 times 5, that covers the 10's prime factorization, and it covers the 5's prime factorization. So we just get 10, which makes sense since 5 is a factor of 10. So we get then that 10 is going to be our lowest common multiple. So how do we convert this then? Well, we already know that this 3/10 here is in terms of 10, so we don't need to touch that. All we need to do is convert this 1/5 into a fraction out of 10. So we need to multiply 5 by 2, right, to get to that point. And we also have to do that to the numerator to make sure it's an equivalent fraction. So 1/5 becomes 2/10, and we're adding it to 3/10. And now, voila, we can add these two fractions because they have the same denominator. They're the same type of thing that we're adding, right? The same size of slices that we're adding. So we have 2/10 plus 3/10. 2 plus 3 is 5, right? We're just adding the numerators. The 10 stays the same. So 5/10, that can be reduced into 1/2. So there you go. 1/5 plus 3/10 is a half. All right, so let's do 3/7 plus 5/16. So the first thing we notice is that they don't have the same denominator, so we need to find the lowest common multiple of the denominators. All right, so 7 is already prime, so that's its prime factorization. 16 can be split up into 2 times 2 times 2 times 2. So notice they have nothing in common, so they're co-prime with each other. So that means their lowest common multiple is going to have to be just the product of all this in order to actually cover both their prime factorizations. So the product of these two, 16 times 7, let's do that on this side over here. It's always good to practice how to do multiplication like this. So 6 times 7, that's 42. 7 times 1 is 7, plus the carry of a 4 gives us 11. So we get 112. All right, so that means their lowest common multiple is going to be 112. So in this case, we didn't really get a nice lowest common multiple. In fact, this is like the worst possible one because, well, it's just their product, right? Their co-prime. But that's all right. We can still deal with this. So to get from 7 to 112, we needed to multiply it by 16, right? So that means we're going to have to multiply this fraction's numerator and denominator by 16 each. And to get from 16 to 112, we needed to multiply by 7. So that means we're going to have to multiply this numerator and denominator by 7 each in order to get our common denominator. So 3 times 16, that's 48. 7 times 16, 112. So 48 over 112 is equivalent to 3 over 7. And then 5/16, well, 5 times 7 is 35. And 16 times 7, once again, is 112. That's our common denominator. So now we just need to add the numerators now that we have the same denominator. So 48 plus 35, what's that going to be? 40 plus 30 is 70. 8 plus 5 is 13. So 70 plus 13 is 83. So we get 83 over 112. And you can check, but 83 is prime, so that means this is going to be as simplified as it gets since 112 isn't a multiple of 83. So 3/7 plus 5/16 gives us this rather girthy fraction of 83 over 112. All right, so adding fractions, it's a little bit of a process, right? We first have to find the lowest common multiple, but then once we have that, it's just simple addition, right? We can also use this method to subtract fractions. So as a visualization to subtract fractions, let's say I have 3/4 shaded in, right? And then what I'm going to do is I'm going to subtract off 1/4. Subtracting off 1/4 is essentially me getting rid of one of these 4 pieces. So we're just left with 2 of the 4 pieces, right? Since we removed this one, so that's going to be 2/4. And we see that just like with addition, Well, since we have this common denominator, we can just subtract the numerators like we normally would, right? 3 minus 1 is 2. And this fourth here is just basically telling us what type of pieces we have. So then when it comes to subtracting fractions where it's a different size denominator, so for example, 2/5 minus 1/4, then what we can do is we can make them the same type of denominator. So we'll find the lowest common multiple of 5 and 4. 5 and 4 happen to be co-prime, so that means their lowest common multiple is just going to be their product of 20. So to find that, we'll have to multiply the first one's numerator and denominator by 4 each to get an equivalent fraction with a denominator of 20. And for the second one, we're going to have to multiply the numerator and denominator by 5 each, right, to get our equivalent fraction with a denominator of 20. So the first one becomes 2 times 4 is 8 over 20. Second one becomes 1 times 5 is 5 over 20. So we get 8/20 minus 5/20 becomes 3 out of 20. And this can't be simplified anymore. So we are done. All right, so let's try one more. All right, so we have 1/5 plus 13/15 minus 2/3. So now we're starting to combine them a little bit, right? But what we want to do is we want to find our lowest common multiple, but this time since it's of 3 different fractions, we want to find the lowest common multiple of these 3 numbers, 3, 5, and 15. Well, lucky for us, 15 is 3 times 5, and 3 and 5 are just prime numbers, so our lowest common multiple is just going to be 15 itself, right? Since that has the 3 and 5 that covers everything. So we're already done with this 13/15. We just need to convert the other 2 fractions. So this 1/5 here, to make this 5 into a 15, we have to multiply the numerator and denominator by 3. And this 2/3 here, to make it into a 15, we have to multiply the numerator and denominator by 5. So then what we get in total is this 1/5 becomes 3/15. This 13/15 is unaffected since we're already out of our common denominator, and then we're subtracting off 10/15. So now it's just all about the numerators because our denominators are the same. So 3 plus 13 is 16, then we're subtracting 10, so we're going to get 6 out of 15. So our final answer is going to be 6/15. Oh, except we can also simplify this, right? Because 6 and 15 are both divisible by 3. Right, so if we divide them both by 3, then that gives us 2/5, and 2/5 will be our simplified answer. Alright, so I hope you found that video useful, and I hope that was a good introduction to adding and subtracting fractions and why ultimately we need a common denominator. Because we're adding pieces of different sizes, that doesn't work. And if you just keep thinking back to this apples and oranges analogy, where in order to add these 2 different types of things, we first needed to think about them as a common type of thing, namely as fruit, and I think that's going to help you out in terms of motivating why we needed a common denominator for adding and subtracting. Well, we're going to get a lot of practice in the next video, so you're going to master this in no time. But until then, have a good one, stay groovy, and I'll see you in that next video.